Hello, this is John Cook, one of the application engineers with Roboris. In this tutorial, I will be showing you how to get started with Eureka3X. I will walk you through installing the software, setting up a project, running simulation, and using some of the evaluation tools. Let's install Eureka3X. Launch the Eureka Setup application. Allow permissions. Select your language from the drop-down menu and click OK. Read the licensing agreement, select I accept, and click Next. Click Next again, and select Install. Click Finish to complete the installation. To launch Eureka3X, simply double-click the shortcut on your desktop. We are going to create a new project from a template. Click File and select New Project. The projects directory at the top is where Eureka is going to put the project folder. In the template drop-down menu, we're going to select the VF2 empty table template. Name your project. I'm going to name this one Project 1, and then I'm going to click OK. Now let's set up the project. We will begin by loading the main program. Right-click on the program node and select Modify. Go to this PC, go to your C drive. I'm going to go to Program Data, Eureka3X. We'll click on Projects. We'll go to HOS VF2 and then to Tutorial Content in Demo 1. Inside the Program folder, select Program 5000 and click Open. You'll see that we have now loaded our main program into our Eureka project. Now let's load the subprograms. We'll right-click on the subprogram node, select Modify. In the macro list dialog box that opens, we're going to select Add. We're going to grab the programs 5100 and 5200, and then click Open. We'll click OK to close out of the macro list. Now we've selected our subprograms for this project. Next, we're going to import the tools for the project. Let's open our tool database by clicking this button here at the top. Notice that our database is empty. We're going to select Import from Folder, and then we're just going to navigate to our Eureka3X. We'll go to Projects, HOS VF2, HOS VF2 Demo 1, and we'll just open up the tool database that is in this project and click Select. You'll notice that when we select one of the tools, we have this little preview here that shows us what tool it is. I'm going to come over here and I'm just going to click the checkbox next to Code and deselect all of my tools. If I just wanted to import, say, Tool 9, 2, and 6, I would just click the box to the left of those tools and click OK. For this project, I need all of the tools that are in this tool database, so I'm going to come up here, click the box next to Code, select everything, and click OK. Now we've imported the tools to our project tool database. Let's click on tool number 1. So let's click one of these automatic position boxes here, and then it's going to zoom to fit, and we can see what tool we have selected. If I click on Code, it's going to order all of the tools in numerical order from 1 to 17. If I click it again, it's going to go 17 to 1. I'll click it over here one more time so that I'm 1 through 17. we'll close out of our tool database. Let's import the stock models we need for the project. Left click on Workpiece, and then left click anywhere inside this yellow notepad. We'll come up here to Shape from File. We'll click there. In our tutorial content for Demo 1, we're going to open the stock folder and select the two solid models that are in there and click Open. Notice that the stock models came in the wrong size. To fix this, we're going to left click on Op1 stock model, right click, and select Properties. We'll change the units to inches and click Apply. Notice that the stock is now the correct size. Let's click OK, and then we will rinse and repeat for the Op2 stock model, change it to inches, and click OK. Notice that our two stock models are now the correct size. We need to define the models to use as stock in Eureka. To do this, we're going to go to the Op1 stock model. We're going to right click and we're going to select as stock. Notice that the icon changed from 3D to this shaded cube. Let's repeat for the Op2 stock model. Now both have this shaded cube, indicating that Eureka is going to use them as the stock models in our simulation. Let's change the document units so the remainder of the solids we import are sized correctly. To do this, we are going to go to Settings, and then Units, and we're going to change them from millimeters to inches. Now we're going to import the workpiece solids. We're going to go to our workpiece node again, click inside the yellow notepad area, and we'll go to Shape from File. We're going to go back to Demo 1, and then we're going to select the workpiece folder, select both of those solids, and click Open. I'm going to hide our stock models so that we can see the part solids. We'll go ahead and show our stock models again, and I'm going to turn off collision detection for the workpieces only. The next thing we need to import is the fixturing for the project. So we're going to left click on our work holding node, click anywhere inside the yellow notepad. And again, we're going to select Shape from File. Going to go back. We're going to go to our fixture folder. I'm going to open up the Op1 Vice folder and select all of the STLs in that folder and click Open. I'm going to click in the yellow notepad area again, Shape from File. We'll go back to our fixture folder. We'll open up the Op2 Vice folder and select all of the STLs in that folder and click Open. Now we have all of our fixturing imported into our Eureka project. Let's go over the mouse functions for Eureka. Notice that the default mode is navigation, indicated by the two arrows chasing each other in a circular manner. In this mode, we can move the Eureka machine around a selected point. If I right-click, it will change to selection mode, indicated by a single arrow. In this mode, I can select individual STLs or solid models in the workspace. We can move the solids in the Eureka workspace. To do this, right-click to go to selection mode. I'm going to select this right vice body, and click on Properties. I'm going to open the Position tab. We're going to move it 10 inches in X, say, and we'll click Apply. Notice that it moved 10 inches with respect to the center of the table. I'm going to enter a 0 and apply to revert to the original position. We can also rotate the solid model about this work holding node. I'm going to go 90 degrees about the Z-axis and click Apply. Notice that the vice body is rotated about the Z-axis of the work holding node. I can click Cancel to revert to my original position. To change the appearance of a solid, right-click to go into your selection mode. Select the solid you want to change the appearance of, and click Properties. Go to the Appearance tab, and click the drop-down by color. Select a color. Next, we can grab this slider to adjust the transparency. We can also directly input a value for the transparency of the solid. I can add a metallic effect, and I can change what that effect looks like. I'm going to select this second option and click OK. We can also create a custom color for the appearance of a solid. I'm going to go to Selection mode and click this left vice. I'll click on Properties and go to the Appearance tab. If I click the drop-down arrow by color and I select Other, I can select inside this area in here in this little color box to select the base color, and then I can grab this slider here to adjust the shade of the color. Once I have the color that I want, I can simply add custom colors. I can select it and then click OK. Turn on the metallic effect, and I'm going to leave it here on this first selection. I'm going to click OK. If I right click, I can see what that new custom color looks like for this vice on the left hand side. I'm going to right click, go to Selection, and then go to Appearance for the right vice. And I'm going to come down here to Other. I'm going to select that custom color that we created and click OK. I'm also going to change the metallic effect to the first option here and click OK. Before running simulation, let's set up the workspace. Check out the Enable/Disable Collision Detection button. Here we can toggle collision detection off, or we can toggle it back on again. For this project, we will want collision detection enabled. I'm going to close all of the open windows and then open them up one at a time. The first window that we're going to want is the Machine Setup bar. This is the window that we've been using to create our project. The next window that you want to open is the Message window. This is where Eureka is going to provide feedback on the simulation. Go ahead and show the Program window. These are the windows you will use when you are running simulation. Before we move on to the next section, let's enable collision detection for the Op1 and Op2 workpieces. To do this, left-click on the Workpiece node. And notice that we have this red circle by Workpiece 1 and 2. This indicates that collision is disabled for those specific STLs. Going to double-click that icon to enable collision detection. Now view your warning settings. Go to Settings and select Warning Settings. Here we can choose what issues we want the simulation to pause at or continue through. The default settings are good, so I'm going to click OK. To view your machining parameters, go to Settings and select Machining Parameters. Here we can set the material removal, visualization, quality versus performance. If I grab the slider all the way and set it to quality, machine simulation will be slower, but the visualization will be very high. Likewise, if I go to performance, it's going to reduce the quality of the visualization, but the simulation is going to be much faster. I usually set it here at the first selection for a happy medium between the two. We can also take a look at our stock updating during simulation. If I click on the drop-down menu, I can select low quality or normal quality. I usually leave it set to the default low quality. Select OK to save your selections. To set your initial work offsets for the Op1 and Op2 programs, click Restart. Let's hide the stock models for Op1 and Op2. To do this, left-click on the Workpiece node and double-click the eye icon to the left of the Op1 and Op2 stock models. Open the Initial Work Offsets tab. Click Add. If you double-click the work offset name, you can change the work offset number. I'm going to keep it at G54 for Op1. Click on Pick Center. Make sure you're in selection mode. Select 3 points on the through-bore diameter to set X and Y. Open the Measure tool. Select Point Position. Go to the coordinate system and change that from plant to work holding. Click OK. Click on a point at the top of the part for our Z0 reference. Note the value right here. We're going to double-click the Z0 field, and we're going to input that value. Hit Enter. Close out of your Measure tool. Click Add. Now we have our G55 for Op2. Left-click it and select Pick Center. This time we're going to select 3 points on the Op2 solid. We're going to open the Measure tool. We are going to select Point Position, and then we're going to select a point at the top of the Part 2 for our Z0 reference for G55. Note the value right here. Let's double-click in this field and input that value. Hit Enter and click OK. Let's show our stock models again. We'll go over to here and we'll double-click the eye for our Op2 stock model and for our Op1 stock model. Let's begin simulation. From the main workspace, let's click the Restart button. This prepares the simulation to run. Next, let's click Simulate All. If we click the button again, we will pause the simulation. Let's click over here to simulate without 3D display. This will simulate the program faster. I'm going to pause my simulation again. Let's go ahead and terminate the simulation. If I click Simulate All, I'll get this dialog box. We'll go ahead and click Yes. And our simulation will begin from the beginning. Now let's navigate to the program window. If you want to view the subprograms, click the File drop-down menu and select the subprogram you want to view. We can click it again and select the Op2 program. I'm going to return to program 5000. Now click the Simulate All button. Let's pause our simulation. Notice that the yellow line is not tracking with the executed lines in the program. Go to View, click on Options. Go to the Simulation tab and enable update data visualization during the simulation. I'm going to change this to always. Click OK to save your settings. Now when I click Simulate All, the yellow line tracks with the executed lines in the program. Notice that the simulation paused after it executed the M1 at the end of the first section, or the first toolpath. If we want the simulation to continue on past M1s and M0s, we can go back to View, click on Options, and go to Simulation. Let's disable Enable Program Stop, and we'll click OK to save our changes. Now the simulation will not pause at M1s and M0s. I'm going to go ahead and place a breakpoint here at line 503, and then start the simulation. You'll see that this simulation is now paused where I put this breakpoint. You can put breakpoints anywhere at any point in time during the simulation, and the simulation will pause at that point. If I click the Simulate Line button, we can step through the program one line of code at a time. Let's put some more breakpoints in the program. This time, I'm going to disable the Neglect Breakpoints button. You'll see the red slash from corner to corner. This indicates that the simulation is going to ignore breakpoints. I will come over here to Simulate All and click Simulate All. We'll go ahead and pause. Notice that we skipped over all of our breakpoints. Let's right-click on line 599 and select Restart from here. We'll click Yes to all of the prompts. Using this function, we can restart the simulation from any line in the program. Let's look at the Breakpoints tab. Click on the tab next to the Program tab. Notice that there is a list of all the breakpoints that have been placed with a reference to the program number and the line number they were placed at. Let's click inside the breakpoint window, and we'll click Add Breakpoint. Let's create a breakpoint that's going to pause at all of the tool changes in the program. We can add a description in the description box. Click OK to accept. Let's disable the first breakpoint by double-clicking the red dot. With the first breakpoint selected, let's go to the Go to Breakpoint location and click that button. You'll see that it brought us to the line that that breakpoint was placed at. Let's enable breakpoints by clicking the Neglect Breakpoint button. Notice the green circle in the upper corner. This indicates that the simulation will now pause when it reaches a breakpoint in the program. Right-click on line 496 and select Restart from here, Update Stock. Click Yes to all of the prompts. Click on Simulate All. Notice that the simulation is now paused at the tool change. If I click Simulate All again, we'll see that it ignored the breakpoint that we turned off in the Breakpoints tab. Let's return to our Breakpoints tab. Let's delete the second breakpoint. Click on it to select, and then click the red X to remove it. We can also remove all breakpoints by clicking this button at the top. Navigate to the Tool Calls tab. It's right next to the Breakpoint tab. Click it to open it. In this tab, you will see all of the tools that have run or are running and the cycle time of each tool. Let's navigate to the Machine View button at the top center of the workspace. If we click it, we'll enter the Workpiece view. Let's go ahead and open the Program tab. and then click Simulate All. Notice that the tooling is now moving around the part. This view gives you better visibility of the operation. Let's go ahead and click Pause, and we will return to the machine view. We're going to check out the message window. First, let's click Restart. We'll click Yes to the prompt. Next, let's go to the File drop-down menu, and we'll select Program 5100. Let's go to the Find button, and we'll search for Tool 2. Hit Enter. Press Enter one more time. We can close out of the Find box. Let's right-click on line 2408 and select Restart from here, Update Stock. Click Yes for all of the prompts. Click Simulate All. The simulation is going to pause at a collision. If you navigate to the message window, you will see an error telling you that there is a collision between Workpiece 1 and Tool 2. Double-click the message, and the line of code that the collision occurred on will be highlighted in gray in the program window. Because the collision is between the workpiece and the tool, we can go to the Workpiece node, and we'll disable collision detection for our Op1 and Op2 workpieces. We're machining out a billet, so there's no need to check for this collision. Let's right-click on line 2475 and select Restart from here, Update Stock. Click Yes to all the prompts. Now when we press Simulate All, we'll see that the collision is no longer reported. Let's go over editing G-code in the program window. Go ahead and restart the simulation. Click Yes for the prompt. If you check out the notes for parameter 511, you will see that if we set the value to 1, it's only going to run the first program. If we set it to 2, it's going to run the second program. And if we set it to 3, it's going to run both programs. If I click in the program window, I can delete the 1 value that was there originally and replace it with a 3 to run both programs. I'm going to return this to a value of 1. Then I'm going to go to the Simulate Without 3D Display and begin simulation. I'm going to click OK, and the stock will update. We can see that only program 1 is run. Let's select program 5100 from the drop-down menu. Let's change the Z value for the positioning move on line 46 to -2 inches. Let's right-click on line 38 and select Restart from here, Update Stock. Click Yes to all of the prompts. Then click Simulate All. The simulation will pause at the collision, and an error message will be displayed in the message window. If we double-click the message, it will highlight the line of code that is responsible for the collision. It's going to tell us that it is between the work holding and the cutter tool 9. Let's change that -2 inches back to 0.1. This time, we're going to open up the MDI window. So we will click it, and this window will open. I'm going to do a G0 Z.1 to return the spindle to the starting position for the toolpath. Next, I'm going to open the controller window. And I'm going to look at this relative position for X, Y, and Z. I want to make sure that the values for X, Y, and Z are the same values that the program specifies on line 45 for X and Y and line 46 for Z. Everything looks good. Let's close out of the controller status window. We can close out of our EMDI window. Let's right-click on line 45. Now we're going to select Set Next Line, and then single block. Through the program. If I zoom in here, I'll see that I am no longer crashing into my fixturing, and the tool is in the correct cutting position to begin the toolpath. I'll select Simulate All. Let's look at the Measure tool. First, let's go ahead and restart the simulation. Click Yes for the prompts. Let's switch to our workpiece view. This time we're going to right-click to go to selection mode. We're going to click on the Op2 stock model and select Hide. We'll do the same for the Op1 stock model. Let's go to a top view in our workspace. To do that, click this top face on the view cube. And then let's zoom in on the part. I want to switch over to an orthographic view. So I'll click this button here and I'll zoom back in. Let's open the Measure tool. You can measure distance between vertices. Let's go to our selection mode and click two vertices, and we'll see the measurement is here in the workspace as well as here in the measure window. Now let's take a look at distances between edges. So if I select that edge and that edge, I'll also get the distance. We can go to faces. I'll go to navigation mode, angle the part a little bit. I'll grab that face, and then I'll come over here to this face and click that to get the measurement as well. The next measurement that we have for distance is circle center by 3 points. I'll select that option there. I'll go to navigation mode. We'll zoom in on this counterbore. I'll select 3 points. I'll go to navigation mode, and then I'll come over here to the second counterbore and pick up 3 points. I'll go back to my navigation mode and zoom out a little bit. We can see that we have the distance between those two bores. To measure the diameter of a feature, let's click this icon here. I'm in navigation mode, so I'm going to zoom in, position myself on this counterbore. I'm going to switch to selection mode. I'm going to grab 3 points on the bore to measure the radius of the bore. I'll see the measurement here in the workspace, and again, I'll see it in the measure window. Let's measure some angles. Let's click this angle type. I'll go to faces. I'll go to navigation mode, and we'll zoom out so that I can see these two faces here. I'll go to selection mode, and I'll select the faces. And we'll see that we have the angle of the faces here in the workspace and also recorded here in the measure window. Let's check out the thickness measure tool. We'll click this icon here. We'll make sure that we are in the selection mode, and then we'll hover over a face. It'll measure the distance between two parallel faces.